And remember that the question said to find the enclosed area between the two curves f of x and g of x, and that the curves were only defined between x is 1 and x is 10. So if we've obviously zoomed out quite a bit from the graphs that we saw in the initial question, but if you were only going between 1 and 10, you can see that actually the only enclosed area is going to be this bit here, the bit that's completely fenced off. Because if we're only starting at 1, then we can't be including this section here, because the enclosed part stretches to prior to x is equal to 1 over here. So that bit's not going to be included. We're just looking at this part here. Potentially we could have just changed these limits to see that a little bit more clearly. If I change that to 1, then I can actually see the graph a little bit more like it looks on the question paper. So this is the area I'm going for. So I'm going to go now onto menu and analyze graph, and I'll choose intersection. I'll find these intersection points here. Same again, analyze graph, intersection, get the intersection points on the right hand side. Maybe move those out of the way. So that's the first part of my question. I'm ready to answer that first part of my question now, because I do now know what the limits need to be for my integration. My x limit for the lower bound is 3.77. For the upper bound, 8.30. Remember, you should be giving an answer to 3 significant figures. This value here presumably has been rounded, so I need to give 8.30. So I'll type those in here. 8.30 at the top, and then 3.77 as my lower bound, and then we've got g of x minus f of x written down here. So that's the expression that would give us the area that we're looking out for. Now our goal is to actually calculate this. So one way we could do it is we could just literally type this in and calculate it on the calculator mode, and it would work it out. If we do that, we just must make sure that we give a higher degree of accuracy for these intersection points than is currently specified here. 3 significant figures is probably not going to be enough for our final answer to be up to the accuracy that we need. Alternatively, there is a function on here, we go analyze graph, where we can do the bounded area. And what we can do is we'll see that if we go to the intersection point, it'll actually highlight it. It means it's really going to snap to that intersection point exactly. So that'll be my lower bound. I can do the same up here. Click for that point there. The intersection point is my upper bound. And I've got 6.46, which should be perfect to 3 significant figures, because it will have used really accurate values down here and up here. Whereas if I typed it in manually, then maybe I'd have a limitation with my accuracy for the final answer.